I wish you a wonderful day and welcome to the ACL YouTube channel. In this video we will talk about how we can utilize the Squid Proxy as filtering and forwarding proxy. What can we do with such a proxy in practice? For example, we can filter HTTP and S connections from our internal networks that are made towards the internet, so that only the required services are allowed. What we will cover in this video will only cover the very basics of installing and setting up the Squid Proxy. We will only add a HTTP proxy listener that can be used for application level proxying, traffic proxying. We will not cover how to set up a transparent proxy using Squid, and we will not cover how we can completely intercept HTTPS with TLS man in the middle. Yeah, these topics are pretty complicated and we will cover them in another video. Yeah, all of the steps and configuration we will mention in this video is covered by the documentation that is linked in the description, so you can copy the config and so on. Yeah. Alright, let's get started. We are here on our demo environment. We also use this demo environment in our NFTables video series, where we cover how we can configure and interact with the Linux Firewall NFTables. Configuring a Linux Firewall will be important once we will cover the transparent proxy setup for Squid. Yeah. Okay, for now, let's install Squid. We are here on Debian 12, so we can use the apt package manager. Exactly. And we want to install the Squid OpenSSL package. The Squid OpenSSL package has support for handling HTTPS built in. The package without OpenSSL has not. So of course we want the one with SSL support. Okay, let's just install it. Yeah. Okay, what do we work with? We are working with a config directory, etc. Squid, and a directory that holds some data for Squid, where we will also add our SSL certificates and so on. Now let us just quickly take a look at the Squid service to find out how it behaves. We have the squid.service here. Let's take a look at the default service file. Yeah, it's pretty simple. And it basically starts Squid and reloads it. So yeah, but there's no real handling for configuration checks before restarting, reloading, and if the service fails, there's also no auto restart. I personally like to add such checks to make the service a little more foolproof, so to say. Forgiving for errors, for human errors, and thus I'll add a systemd override to add that functionality. We'll add a directory for that override. Of course, you don't need to configure this override, but I'll show you how to do it if you'd like to do so. Yeah, we'll add that override configuration file. Basically, what we're doing here is overriding the start pre and the reload actions to add a configuration check in before, so the reload or restart isn't performed if some configuration is invalid. Also, we have added auto restart if the service is failing. Yeah. As this is a major networking service and many systems in our network will depend on it, I would recommend to add that configuration check. As we've seen, using the systemctl daemon reload, we can activate these changes. Of course, we will have to restart the service to make them active. And also, don't forget to enable the service. Systemctl enable squid.service, so the service gets started on system boot time. We can, of course, also perform the configuration validation manually whenever we do make changes to the configuration using the squid-k parse-f and then the main configuration file. And it will validate the configuration, show us some errors. How can we check if any error has occurred? We can check out the exit code using the $ and question mark. If the exit code is 0, the configuration is valid. If we add some invalid configuration here, just to test it and reparse it, the exit code isn't 0, it is 1, and we can see there's an error. Yeah. Now, what will we have to prepare before we start to configure Squid? We will have to add some certificates, so the SSL handling of Squid works. We will first create a directory for the SSL certificates under user share Squid. We'll call it SSL and change the privilege on it so other users cannot read its contents. Then we will create a snake oil, some self-signed certificate just as a placeholder, and a Diffie-Hellman key can be used by the Squid. Then we'll make sure the proxy can read those certificates, and we will also have to create a SSL database, in this case with a size of 20 megabytes. And also make sure that the proxy user can read and write into that SSLDB. Now we can start to configure Squid. In my case, I will start with deleting the default Squid configuration because I already know what I want and need to configure. If you're new to Squid, you might want to copy it, save it, its content, because there are many options in there that might be interesting for you. Okay, let's just remove it and create a new empty configuration in this case. And where we will start, we will always start with listeners. We will need to tell Squid on what ports to listen on and with what protocols, proxy protocols, Squid should listen on those ports. As mentioned before, we will start with a basic HTTP proxy listener that can be used by client applications. So this is the very basic HTTP listener config. We will also add TCP keep alive config. You don't need it, but I personally like to set it. And then we will enable SSL handling. So HTTPS traffic can be handled by this listener using the SSL bump feature. And we will also configure some options for that SSL bump, for that SSL handling. Let's just quickly go over those options. We have our snake oil certificate and key as we've created them. Then we deny some weak ciphers, deny deprecated or unsafe SSL TLS protocols, and then we reference the Diffie-Hellman key we created previously. Okay, let's just add that to the listener. Then we'll start with some basic options. As we can see, Most of them are for log handling, how Squid is behaving. In that regard, we have a custom log format that contains some more information than the basic log format, like user agent and referrer. We are logging here to syslog. You can, of course, also log to a log file. Just replace the syslog string with the path to the log file. If you use a log file, you might also want to add a timestamp format in front of the log format, so that the timestamp gets added to that log line. If we're using syslog, syslog is handling the timestamp creation, so it would be redundant to have it. As we are not using a cache, we disable those logs. Also, we don't need the log file rotation that is built into Squid. Yeah. And the has request condition is basically to filter out invalid requests. For example, if you have some monitoring solution that checks the Squid board, if the Squid board is alive and reachable, it might send some TCP packet to that board, and whenever it gets a TCP response, it's happy and doesn't continue with the request. So it would be an invalid request for Squid, and it would log such requests. So I personally like to remove those invalid requests from the log file. Yeah, and then we configure a memory cache and lower the shutdown lifetime to 1 second in this case. The shutdown lifetime, as I have understood it, is to finish requests, running requests on restart shutdown of the service. But yeah, you can, of course, just change configuration if your environment needs some other settings. Yeah. Then we have some options, some security relevant options to harden the configuration of Squid. By default, Squid will expose some information to its clients using response headers, like the Squid version, that Squid is actually handling this request, and also if the request has hit cache and so on. Also a forwarded for header could be added. We don't want to expose that information because it could lead to some easier exploits of the service. So we just deny or just remove all of that information. Exactly. Then for outbound connections from the proxy, we also disable weak ciphers and old SSL TLS versions. And we have some IPv6 base rulers. And at last, if we are using our proxy in a default enterprise setup, we should always limit the source IPs that are able to send requests over our proxy. Else some unwanted IP, some attacker might be able to send traffic over that proxy, especially if the proxy is available on the public internet for some reason. We of course can also define a user password that need to be provided to the Squid proxy, so only authenticated requests can be sent over the proxy. Yeah, now let's take a look at the option settings that are used for SSL HTTPS handling. First option we will configure is the one that will reference the SSL database that we have created previously. After that, we define which traffic is actually TLS traffic that we want to inspect. We also limit the usage of the connect method, as if we allow it unrestrictedly, clients could be able to create a connect tunnel through our proxy and actually proxy any traffic through it without our ACLs or filters actually working. We also only peek at the TLS connection here. We do not act as a man in the middle and break up the TLS connection. We only read the server name identifier, the SNE. This allows us to filter on a destination domain basis. This is very useful for beginners if you don't use a web proxy. So you can start to create a basic rule set of domains that are allowed in your environment without having to handle the whole SSL termination and many funny issues that come from it. So this is a very basic SSL handling for now. We also have defined some cache size, session time to live, and Squid is also checking server certificates for validity. So if the server certificate is expired or from an unknown certificate authority, self-signed, something like that, we can actually deny connections to that server. Of course, we can also exclude some domains from that check if you need to do so. Yeah. Finally, we have to add some ACLs, some filters that allow or deny traffic over the proxy. In our case, we will deny any connection that is not targeting port 80 or 443, so HTTP or S, and for testing purposes, we will allow connections to any target that is not specifically denied beforehand. Of course, in practice, you will always want to deny all the traffic that you not specifically allow. We will also work with that restriction later on. But for now, let's check if the proxy is working at all. And yeah, we'll do so after restarting our Squid service. So the configuration changes get loaded. Of course, we can check if the configuration is valid. Let's do that again. Yeah, looks good. And now we can restart our service. Reload it. Better restart it. Okay, after the restart, the listener on port 3128 should start. And our client should be able to connect to it. But one more thing we have to configure is our firewall. The server, the client and the firewall share a layer 2 network, but we will have to allow the client to access the port 3128 on our firewall for now, for our tests. Yeah. In this case, we'll add a allow rule in our input chain, as this is traffic that comes to the firewall, and we'll configure that any private network is able and allowed to connect to that proxy port. Let's just reload our nftables config in that case. And now our client should be able to reach our proxy. Our client cannot connect to any internet service without the proxy because we have denied those connections using the firewall. You see, it gets a timeout. But if we specify the proxy specifically, so we add the environment variable HTTP proxy in front of curl. It will use the proxy and should be able to reach the destination server. So we'll add HTTP proxy, the environment variable. HTTP is the protocol that we'll use to connect to the proxy. This is the IP of the firewall and the port of the proxy, and yeah, we are able to connect to the internet over the proxy. Nice. We can also see that connection in our Squid logs using journal.zetl in this case. Okay, so far so good. Let's test if HTTPS connections work, so we can target HTTPS servers over our proxy. We can do that by adding a S on the URL and also specifying the HTTPS proxy environment variable. And we see the connection. We can see HTTPS creates two logs in our Squid logs. One is for the connect tunnel to the Squid, and the other log is for the actual connection to the destination server. If we now want to restrict access over our proxy, we will have to set the default policy to deny, as we have done here. Now reloading the Squid config so it gets activated, and then we'll try to connect over the proxy again. We see, okay, it's a forbidden. We are trying to connect to an internal server here that is in another subnet than the client. And for now we will allow connections to other internal IPs, and we see the connection is working again. So we can allow connections using destination IPs. Of course, we don't always know the IPs of our destinations if it's some internet service or something like that. For that, we will need to allow destination domains. We'll showcase that now. If we connect to OXL AT, we see an error. We get forbidden and some generic error template. That error template, if I remember correctly, also contains some information that Squid is blocking that request and maybe even its version, don't know. For now, we'll remove that default template and add a smaller generic one. You can change those templates to whatever you want. Now reload, so the templates get loaded. And let's retry it. Yeah, and the access denied template is updated, and we see it was forbidden. The connection was forbidden. Now, as we have SSL bump peak set up, Squid actually knows the destination domain of SSL targets, HTTPS targets, and in this case it's a HTTP target. Therefore, Squid can read the HTTP header and also know the destination domain. You see, connecting to a HTTP target works as we have allowed it, and connection to a HTTPS target to this target. This is the connection to the proxy, and the server, the WAF, has denied the request, but we're actually connecting to the real server on the internet. So it works. That is pretty nice to have, to create basic rule sets using destination domains. We can also add multiple destination domains to one ACL. We'll see that later on. For now, it's just test to connect to Google for testing purposes, as we have got a 400 error message or error code on the last connection, and we can see we get a redirect from Google. So works. Okay. Yeah, that's pretty nice to have. Destination domain matching. You can create pretty nice rule sets using that functionality. Now, as a last example, I will showcase some more advanced ACLs, so to say. I might create another video on the topic of Squid ACLs itself, because there are many kinds of ACLs. And yeah, for this example, we have a time defined, the time of day, and also two domains or wildcard domains. If you add a dot in front of a domain, all of the subdomains also are matched. So we allow any YouTube domain and any Facebook domain in this case, in this ACL. And you can see we allow those access to those domains in that time period. So yeah. Okay, that's it for now. I hope you could learn something. I hope it was interesting. If you have some questions, please put them in the comments. If you need support for some advanced setups, contact us directly. We're happy to help you. And for now, have a nice day and servus.